morning students. So far we have discussed about the hyperbola to be the conic whose eccentricity is greater than 1, and we have derived the equation of the hyperbola x square by a square minus y square by b square equals to 1, and we have also discussed about the conjugate hyperbola and rectangular hyperbola, and we have discussed about the various forms of the hyperbola whose center is at the origin and whose center is not at the origin. That means shifting of the origin. And we have also discussed the various terms involved in the hyperbola like chord, focal chord, double ordinate, latus rectum, etc. And we have derived the equation of the tangent and normal to the hyperbola both at the Cartesian point px1 y1 and the parametric point. Hence, you are all requested to watch the first 2 videos before watching this video. And now, let us solve some examples prior to begin the exercise 5a. So, this is the example number 1. Find the center, eccentricity, foci, directrices and the length of the latus rectum of the following hyperbolas. These are the 2 hyperbolas that are given. So, first one, given equation of the hyperbola is 4x square minus 9y square minus 8x minus 32 equals to 0. So, this is 4x square minus 8x minus 9y square minus 32 equals to 0. So, this is, I'll take 4 in common in both of them. So, 4 into x square minus 2x minus 9y square minus 32 equals to 0. This implies 4 into x square minus 2x. That means a square minus 2ab term is there. Additionally plus b square, if I add and subtract, then a square minus 2ab plus b square will become a minus b whole square and minus b square will be left over. So that's what we are going to do here. So here x minus the quotient of x is 2, half of it. 2 by 2 is 1. So 1 whole square minus 1. So by writing this x minus 1 whole square minus 1, this is equals to this only, because x square minus 2x plus 1 minus 1 gets cancelled. So this is what we have left with. Minus 9y square minus 32 equals to 0. This is 4 into x minus 1 whole square minus 9y square minus 32. So 4 into minus 1 is minus 4 equals to 0. Plus 4 into x minus 1 whole square minus 9y square is equals to minus 36 will become plus 36 on transposition. So this is 4 into x minus 1 whole square minus 9y square by 36 equals to 1. So this is 4 into x minus 1 whole square minus 9 into y minus 0 whole square. We can write by this is 36. So is equals to 1. Therefore, x minus 1 whole square 4 by 36 is 9 minus this is y minus 0 whole square by, so this is 4 times is equals to 1. So this is of the form x minus h whole square by a square plus minus y minus k whole square by b square equals to 1. So this is the hyperbola whose center is not at the origin. Origin is shifted to h comma k. So which kind of a hyperbola is it is? This is normal hyperbola. It is not a conjugate hyperbola. Conjugate hyperbola is y minus k whole square by b square minus x minus h whole square by a square equals to 1. So here h is equals to 1, k is equals to 0. H is equals to 1, k equals to 0, and a square is equals to 9. From this a is equals to 3, b square is equals to 4. From this b is equals to 2. Therefore, this is a hyperbola, so whose center is C h comma k is equals to 1 comma 0, which is obviously not at the origin, not a standard form of the hyperbola. It is the shifting of origin has taken place here now, and the transverse axis is parallel to, because this is not the regular hyperbola, standard hyperbola whose center is at the origin. So this is y is equals to k. Now what do we require here? Center we already get. Therefore center C h comma k is equals to, this is 1 comma 0. Eccentricity E is equals to, here A is greater than B. Here a square plus b square by whichever is greater, that will come under the denominator. So this is a square. So this is 9 plus 4 by a square. A square value is 9. So this is root 13 by 3. Now eccentricity we have found. Foci is s comma s dash. So for the hyperbola whose vertex is at the origin, whose center is at the origin, the foci are plus or minus ae comma 0. But here shifting of the origin has happened. So for this plus or minus ae with x coordinate h would be added. For this k would be added. So this is equals to h value is 1 plus or minus a value is 3 into e value is equals to root 13 by 3 comma k value is equals to 0. So 3 gets cancelled. So we get 1 plus or minus root 13 comma 0. 1 plus root 13 comma 0 s. 1 minus root 13 comma 0 is s dash. Now, so length of the lattice rectum. Length of the lattice rectum is equals to 2b square by a. But for the conjugate hyperbola, x minus h whole square by a square minus y minus k whole square by b square equals to minus 1. For that 2a square by b. So here 2b square by a. B square is 4. 4 into 2 8 by a is 3. So this. And now equation of the directrices. Equation of the directrices is equals to. So for the hyperbola whose center is at the origin, these two are the directrices. These two directrices are the lines which are parallel to y axis, x equals to, these two are a by e comma 0 minus a by e comma 0. Therefore x is equals to plus or minus a by e comma a by e. So for this, since shifting of the origin happened, h will be added extra. X is equals to h plus or minus a by e. From this, x is equals to, the value of h is equals to 1 plus or minus a by e. A value is 3 by e value is, a value is 3 by 1, e value is root 13 by 3, it will be reversed, 3 by root 13. So 9 by root 13. So if you take an LCM here, root 13x is equals to root 13 plus or minus 9. 4 into y plus 3 whole square minus 9 into x minus 2 whole square equals to 1. So this is the given hyperbola. So this is equals to 4 into y plus 3 whole square minus 9 into x minus 2 whole square equals to 4. This can be written as y plus 3 whole square by, this can be written as 1 by 4 minus x minus 2 whole square by, this is 1 by 9 is equals to 1. So this is the form y minus, this is equals to y minus of minus 3 whole square by 1 by 4 minus x minus of 2 whole square by 1 by 9 is equals to 1. So this is of the form y minus k whole square by a square minus by b square minus x minus h whole square by a square is equals to 1. So this is a conjugate hyperbola whose center is shifted to C h comma k, which is h here is, so minus minus same, in the place of h you may see 2 here, so 2 comma the value of k is minus 3 here, so minus minus same, in the place of k you may see minus 3 here. So this is the center and whose transverse axis, for the conjugate hyperbola whose center is at the origin, the transverse axis is y axis, in other words x equals to 0, but here is parallel to x axis, parallel to for the conjugate hyperbola whose center is at the origin, the transverse axis is along the y axis. Along the y axis, x equals to 0, but here parallel to y axis, that is x equals to h here. So a square is equals to 1 by 9, b square is equals to 1 by 4. So from this, a is equals to 1 by 3, b is equals to, a is equals to 1 by 3, b is equals to 1 by 2. Now the eccentricity E is equals to eccentricity is equals to a square plus b square by, which is bigger here, b square or a square? So whichever, actually for that a square plus b square by a square for the hyperbola, but here a square plus b square by b square. So a square is equals to 1 by 9 equals to 1 by 4 by b square is equals to 1 by 4. So this is equals to 4 plus 9, 13 by 9 4s are 36. This is 4 by 1. So 4 9s are 36. This is equals to root 13 by 3. This is root 13 by 3. This is the eccentricity. And length of the lattice rectum. Length of the lattice rectum is equals to, for the hyperbola, x square by a square plus minus y square by b square equals to 1. 2b square by a is the length of the lattice rectum. But here, for conjugate hyperbola, it is 2a square by b. So 2 into a square is equals to 1 by 9 by b is equals to 1 by 2. So this is 2 by 9, 2 into 1, so 4 by 9. So this is the length of the lattice rectum. So the foci is equals to, foci s comma s dash is equals to 0 comma plus or minus be for the conjugate hyperbola whose center is at the origin. But here shifting of origin has been happened. So with the x coordinate h would be added. With this k would be added. So this is h comma k plus or minus be. So h is equals to, h here is 2, k value is minus 3 plus or minus, the value of b is 1 by 2 into the value of e is root 13 by 3. So this is 2 comma minus 3 plus or minus root 13 by 2 3s are 6. So 2, 6 minus 3 is minus 18 plus root 13 by 6. Now equation of the directrices. Equation of the directrices. So for the conjugate hyperbola, this is the conjugate hyperbola whose vertex is at the origin. So these two are the directrices. These two lines are parallel to x-axis. These two lines are parallel to x-axis. So parallel to x-axis, y is equals to something. So y is equals to plus or minus b by e there. Plus or minus b by e for the conjugate hyperbola whose center is at the origin. But here this is the concept. So origin has been shifted. Therefore, with this additionally k would be added. So k value here is equals to minus 3 plus or minus b by e. B value is 1 by 2 by e value is root 13 by 3. So this is equals to minus 3 plus or minus 1 by 2 into 3 by root 13. So this is equals to, y is equals to minus 3 plus or minus 3 by 2 root 13. So 2 root 13 y is equals to minus 2 3 is 6 root 13 plus or minus 3 is the equation of the direct resonance. How do we know all of them? So just by remembering the two concepts, that's it. What is that? Hyperbola, x square by a square minus y square by b square equals to 1, and the conjugate hyperbola, x square by a square minus y square by b square is equals to minus 1, or y square by b square minus x square by a square equals to 1. So if you multiply with minus on both the sides, so you just have to remember for these two only, and the two more hyperbolas with the shifting of origin. All that we need to do is, for x you keep on adding h, and for y you keep on adding k, then we will get the formula easily. If E comma E1 are the eccentricity of a hyperbola and its a conjugate hyperbola, prove that. If E comma E1 are the eccentricity of a hyperbola and its conjugate hyperbola, prove that 1 by E square plus 1 by E1 square equals to 1. So, for the hyperbola, x square by a square minus y square by b square equals to 1, the relation among a, b and e is b square is equals to a square into e square minus 1. From this, e is equals to square root of a square plus b square by a square. Now, for the conjugate hyperbola, x square by a square minus y square by b square equals to minus 1, or y square by b square minus x square by a square equals to 1. So, a square, the relation among a, b and e is a square equals to b square into e square minus 1. But for the conjugate hyperbola, the eccentricity is E1. So this is E1 square minus 1. So from this, E1 is equals to square root of a square plus b square by b square. Now, given that, so for your information, this hyperbola is like this. This is the hyperbola and this is the conjugate hyperbola. For this hyperbola, the transverse axis is along x-axis and the conjugate axis is along y-axis. For the conjugate hyperbola, the transverse axis is along y-axis and the conjugate axis is along x-axis. Now, given that 1 by e square plus 1 by e1 square, this is equals to, so e is this, e square is square and root gets eliminated, and 1 by e square is the fraction would be reversed. This is a square by a square plus b square, and 1 by e1 square is b square by a square plus b square. So this is a square plus b square by a square plus b square. So this is equals to 1. If the line Lx plus My plus N equals to 0 is a tangent to the hyperbola x square by a square minus y square by b square equals to 1, then show that a square L square plus b square m square is equals to n square. The second bit is, if the line, the same line, Lx plus My plus N equals to 0 is a normal to the tangent, then this is what we need to prove. A square by L square minus b square by m square equals to a square plus b square whole square. That means, this is the hyperbola So center S dash L equals to 0, L dash equals to 0. So let us suppose that this is the tangent. Let us suppose that this is the tangent at this parametric point P theta. The parametric point for the hyperbola is A secant theta, B tan theta. So this line is Lx plus My plus N equals to 0. Let this be L. So the directrices are L equals to 0, L dash equals to 0. So let us take this to be L. This will be other than L, L dash. Directrices are M, M dash. Okay, that is not necessary here. That is not required here. So L is Lx plus My plus N equals to 0. Let the line Lx plus My plus N equals to 0 be a tangent to the hyperbola x square by a square minus y square by b square equals to 1 at the parametric point. So now the equation of the tangent at P theta to the hyperbola S x square by a square minus y square by b square minus 1 equals to 0 is S1 equals to 0. So that is, what is the parametric point? X by a secant theta minus y by b tan theta minus 1 equals to 0, where x1 y1 being a secant theta, b tan theta. So now L equals to 0, that is this, and S equals to 0 also this. Because what is S equals to 0? S1 equals to 0 is the equation of the tangent at P theta. So both L equals to 0 and S1 equals to 0. This is S1. So now L equals to 0, S1 equals to 0 represents the same lines. Comparing coefficients, we get so the coefficient of x here is secant theta by a by, here quotient of x is L, is equals to coefficient of y is minus tan theta by b by m, is equals to constant is minus 1 by n. So this is equals to a by b by c, a by bc. So secant theta by an is equals to minus tan theta by bm is equals to minus 1 by n. So from this, secant theta is equals to minus al by n. Secant theta by al is equals to minus 1 by n. So comparing these two, we'll get this. Now tan theta is equals to, so bm by n. So tan theta is, so minus on both the sides gets cancelled. Tan theta is equals to bm by n. Now we know that secant square theta minus tan square theta equals to 1. Secant square theta is minus al by n whole square. So this is a square l square by n square plus bm by n whole square minus b square n square by n square is equals to 1. So therefore n square LCM if you take and transpose onto another side, a square L square minus b square m square is equals to n square is what we need to prove. So this is not plus, minus is given in the question. Now if the line Lx plus My equals to 1 is a normal to the hyperbola x square by a square minus y square by b square equals to 1. So let us suppose that this is the tangent. So the line perpendicular to this tangent at the parametric point p theta is this. So therefore this normal is Lx plus My equals to 1 according to the question. So let the line Lx plus My is equals to 1 be a normal to the hyperbola, to this hyperbola. This is the normal at the parametric point. So equation of the tangent of the normal at p theta to the hyperbola is, let us suppose that to be n, ax by secant theta plus by by tan theta is equals to a square plus b square. So here Lx plus My equals to 1 is the normal according to the question. So the same normal is this we got at the parametric point. So here n comma L represents the same lines. So let us compare the coefficients. So here the quotient of x is a by secant theta by x quotient is L here is equals to y quotient is b by tan theta by m is equals to this a square plus b square on transposing minus of a square plus b square equals to 0. This equals to 1 on transposing, minus 1 equals to 0. Now this is minus of a square plus b square by minus 1. So this is a by secant theta by L. So a by L secant theta b by m tan theta is equals to a square plus b square. So from this, comparing first and this, will get a by L secant theta is equals to a square plus b square. From this, a by a square plus b square, a by a square plus b square into L, a by a square plus b square into L is equals to secant theta. Similarly, b by m into a square plus b square is equals to tan theta. So we know that secant square theta minus tan square theta is equals to 1. So secant square theta is a square by L square into a square plus b square whole square minus tan theta is this. So b square by m square into a square plus b square whole square is equals to 1. So from this, 1 by a square plus b square whole square, if you take common, then this is a square by L square minus b square by m square is equals to 1. Therefore, a square by L square minus b square by m square, this is 1 by a square plus b square whole square. So this is this fraction would be reversed if you transpose. This is equals to a square plus b square whole square is what we need to prove. Find the equation of the tangents to the hyperbola 3x square minus 4y square equals to 12, which are parallel and perpendicular to the line y equals to x minus 7. Whenever you are given a point px1, y1 and we are asked to find out the equation of the tangent, then the equation of the tangent at px1, y1 to the hyperbola s equals to 0, s1 equals to 0 will be used. But here no point is mentioned in the question, but he is giving a line and the parallel and perpendicular is what he has mentioned, and in some more problems he will give us the inclination. So what is that is related to this parallel, perpendicular or inclination? That is slope. So let us take the slope form of the tangent for solving this kind of problems. Solution: equation of the given hyperbola is 3x square minus 4y square is equals to 12. So this is equals to x square, 3x square minus 4y square by 12 equals to 1. So this is x square by 4 minus y square by 3 equals to 1. So this is the hyperbola, not the conjugate hyperbola. So a square equals to 4, a is equals to 2, b square equals to 3, b is equals to root 3, and whose center is at the origin, standard form of the hyperbola. So given equation of the line is y is equals to x minus 7. So this is x minus y is equals to x minus 7. The slope of this line is y is equals to mx plus c, m equals to 1. So if the slope of this line is 1, so what is the slope of a line which is parallel to this line? That is also having the slope m equals to 1, because two parallel lines are having the same slopes. Therefore the slope of a line parallel to the given line is also m equals to 1. Now the slope form of the tangent is y is equals to mx plus or minus square root of a square m square minus b square. So this is equals to y is equals to x plus or minus square root of a square 4 into m square is 1 square minus b square is 3. So therefore y is equals to x plus or minus 4 minus 3 is 1. So these therefore x minus y plus 1 equals to 0 and x minus y minus 1 equals to 0. So I have taken plus ones and the minus ones, then these are the equation of the tangents. Now the slope of the given line is m equals to 1. So the line which is the slope of a line which is perpendicular to the given line is m equals to minus 1, because 1 into minus 1 equals to minus 1. So the product of the slopes is equals to minus 1, then those two lines are perpendicular to each other. So equation of the tangent having slope m equals to minus 1 and slope m equals to minus 1 is y is equals to mx. So minus 1x plus or minus square root of a square. A square is 4, m square is equals to minus 1 whole square minus b square is 3. So this is equals to y is equals to minus x plus or minus 1. 4 minus 3 is 1. So therefore x plus y, if you take plus 1s and minus 1s, so plus 1 equals to 0 and x plus y minus 1 equals to 0.